Hey guys, welcome back. So today we're going to revisit the fundamental theorem of calculus in a very similar way to what we did yesterday, but also kind of maybe a little different, though not really. You just may not realize it. Okay, so before we get started, this isn't necessarily something we've done before, but this is something I think you can do. If you take a moment, hit pause, look at the fact that you're given the derivative equation, but you're asked for a new value. Okay, so we need to find f of x. So you're going to do the antiderivative, find f of x, and then once you have an equation for f of x, find f of 5. Now I'll give you a hint, this does matter. Hit pause and see if you can figure that out on your own. Okay, so to find f of x, we're going to integrate that 2x, right? So f of x would be the integral of that power rule. You'd get x squared, but this is where you have to write plus c. Because remember, we don't know if the original function is the original function x squared plus 2, or is the original function x squared plus 20, because the derivatives of all of those are still going to give you the correct derivative. So you really need that plus c right now. And now is when, in order for me to find f of 5, I'm trying to plug in f of 5. Well, now I have to know what that c is. So to find that c, you need another point. You're going to plug in x of 1 and a y of 3 in order to solve for c. So I'm going to plug in x is 1 and y is 3. Solve for c. Subtract 1 after you square it, and c has to be 2. Hey, that's funny. I didn't know I was going to guess right that first time. So now I plug that 2 in right here. And the actual function, the original function, f of x, would just be x squared plus 2. That's the legit function. Double check. When you plug in a 1, you should get a 3. Okay? And you do. So now we can find f of 5, which was the question. F of 5 would be 5 squared plus 2, 27. Done. Now, that's what you do if you want to solve for c. Okay, this is option 1. The problem with this method is you don't realize it quite yet. You haven't gotten far enough yet, but not everything can be integrated. It's not always possible. Now, in the AP exam, they often give us things right here that you can't integrate by hand, and you need a calculator. So if I can't integrate by hand, I cannot write this equation, and I can't solve for c. So there's another method to solve these problems, and that's what today's lesson is going to be about. So we will be doing this problem again after this lesson. Okay, so first, let's go back to something you've done a million times. Okay, remember, when you evaluate a definite integral, and a definite integral is just one that has bounds. Okay, when you evaluate a definite integral, you don't need the plus c. And that process of plugging in the 3 and the 1 and subtracting, that evaluating of a definite integral, that has a name, and it's the fundamental theorem of calculus. Okay, so every time you evaluate a definite integral, that's the fundamental theorem of calculus. So we already know how to do this. Add 1, divide by the result, and you get x squared. Oops, x squared evaluated from 1 to 3. You plug in the 3 first, then the 1, and you subtract. 3 squared is 9, 1 squared is 1, my answer is 8. Okay, so we did the antiderivative and then plugged in these two bounds. Well, that is actually the fundamental theorem of calculus. I know you know that, but we're going to be rearranging that theorem today. So here's the formal theorem. You don't need to write this down, it's fine. Okay, just want to show you the lingo. Notice that they, in this particular version, they define capital F to be the antiderivative. So this says, whatever this guy is, capital F is the antiderivative, and then they plugged in a B and an A. So this is what we've been doing all along whenever we do a definite integral. No big deal. All right. If you want to use different symbols here and instead you want to use the derivative symbol, then it would look like this. This is the same thing. Okay, same exact thing, no big deal. If I use a derivative symbol here instead of that capital F thing that they did, then when I integrate, we'd get the antiderivative, okay? And then we would plug in the bounds B and A. So that's the same thing we've been doing all along, no big deal, okay? Now, for today's lesson, I'm going to rearrange that. So what I'm going to do for the heck of it, you'll see why at the end though, I'm going to algebraically saying, I want to solve for f of b and get f of b by itself. So I'm going to add f of a to both sides. Okay? And hopefully you can see what that would result in. This would go away. We'd get f of b equals this. We'd put the plus sign there. Okay, so I have that on my PowerPoint. Let me show that. Okay, make sure you understand where that came from. This is from adding this guy here and putting it, oops, sorry. This is from adding this guy here and moving it to the other side and making it positive, okay? Yes? Okay, now I'm just going to rearrange and put this guy on the other side and rearrange the equal sign. And here we go. Now, this is what we're going to work with today. Can you see, hopefully, that this new version I've got here is really the same as the original fundamental theorem of calculus? Hopefully you can see I've just moved that guy over. Okay? Now, how do you read this? Okay? This says, if I have a derivative, but I'm asked for an antiderivative at a point, then I need to know another antiderivative at a point. Okay? And to get my new value, it's the starting value plus the net change from what I know to what I need of the derivative. And let me try to say that again. Okay? And I'm going to have to do a bunch of these before you get into a pattern, okay? But anytime they want you to find an antiderivative at a point, like f of 7, okay? But what they give you is f prime, okay? If they give you an f prime equation and ask for an antiderivative, like I did on the bell work, then you need to know another value, like f of 7. It could be any number, though. Maybe an f of 2. They got to give me one, okay? In order to find f of 7, I would take f of 2, the one I know, and then integrate the derivative from the one I know to the one I need. Okay, that's how that's going to work. This is the one you're trying to find. This is the one you know. And you're going to integrate from the one you know to the one you need. And you kind of want to just get into a pattern of visualizing. If you subtracted this and moved it to the other side, can you see that that would match the order of when you do the antiderivative? You would plug in the 7 and then the 2. Okay, so let me erase all of this. Okay, this is what we're dealing with today. To find an antiderivative, you need another antiderivative, and then you integrate from what you know to what you need. Try to memorize that right now. I call it starting value plus net change. And everything we did yesterday is kind of like that, except our starting value was time of 0. So we started at 0 and went from 0 to whatever. It's kind of the same thing we were doing yesterday. It just made more sense when you started at 0. All right, so here is the same question we did for bell work. Hopefully you remember the answer to that was 27, I think. So using the new way of doing it without solving for C. Okay, you have two options. Again, you can solve for C if this is something you can integrate, or you're going to do what we're doing right now, which is usually what we have to do because usually this is something that you can't actually integrate. Okay, so here we go. Training. To find f of 5, and always write it formally till you get used to it. F of 5 will be f of 1 plus the net change from 1 to 5 of the derivative. Okay? You want to write this over and over again. Always write out just like this with the 1 and the 5. Don't write what actually it equals because you've got to train your brain to get used to the fact that the 1 goes here and the 5 goes here. Okay? And again, visualize moving this term over to the other side and you can see you would be subtracting the 5 and the 1, which is the correct order. All right, now what do I do with this? To find f of 5, it will be f of 1, which is 3, plus the integral from 1 to 5 of 2x. I then actually integrate this, and I'd get x squared evaluated from 1 to 5. So it'll be 3 plus, plug in the 5, plug in the 1, and subtract. So 5 squared, 1 squared. So that is 3 plus 24, which is still 27, the same answer. Okay, now is one way easier than the other? I don't know. It's about the same to me. I don't think one's much different than the other as far as difficulty level. But again, this one you have to do 2 times actually. When this can't be integrated by hand, which will happen. And also this helps when you're trying to get an integral on a graph. Okay, when you're looking at a graph, you'll need this, which we're not really doing right now, but that'll happen too. All right, so try it again. Do this one. I want you to hit pause and see if you can just set it up correctly. Okay, the one I need, f of 3, is equal to the one I know plus the net change from 1 to 3 of the derivative. Okay, remember, this guy has to be the derivative, and these guys are antiderivatives. Okay? Now it's just a matter of solving. F of 3 will equal f of 1, which was 5, plus the integral from 1 to 3 of 3x squared. Now bring down that 5 and integrate. Okay, that's going to be add 1 to the exponent and divide, and we'll get x cubed, evaluated from 1 to 3. So it's 5 plus, plug in the 3, plug in the 1. Plugging in a 3, I get 3 cubed, which is 27. Plugging in a 1, you get 1. So this is 5 plus 26, or 31. Did you do it on your own? Okay, so now the thing is, today I'm going to be giving you things that you can't integrate by hand. So you won't be doing this part by hand. Instead, you're going to take this piece right here. Actually, take the whole thing. Once you write it on paper, then you're just going to put it in your calculator using Math 9. So you do 5 plus Math 9 and then put this in, because this is going to be something you can't integrate by hand. Okay? So now let me just work on training you. It doesn't matter what that derivative is. It's going to be ugly. The derivative equation is going to be ridiculous, something you can't integrate by hand. Okay? So all you're practicing right now is the setup. Okay? So on your paper, hit pause and write down the setup for this problem. Okay, g of 9 is equal to g of 4 plus the net change from 4 to 9 of the derivative, whatever that derivative will be. That's what you have to write on your paper, okay? Then in your calculator, you'll do 7 plus Math 9, and you'll plug in whatever g prime is, okay? It's going to be a calculator issue. You want to try another one? Let's say I ask for k, oops, backwards. Okay, let's say, I'm going to just throw a bunch out at you now. Let's say I ask for k of 15. I give you k prime of x is, I don't care, blah, 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 whatever it is. And I also give you k of 1 is negative 4. Okay, practice the setup. Hit pause. Okay, k of 15 will be k of 1 plus the net change from 1 to 15 of the derivative. Okay, one more. This one's going to be a bit of a trick. Maybe, maybe not. Let me think. Okay, this one isn't really a trick, but I don't want it to trick you in the future. So do the same thing. Take a minute, hit pause, and write down the setup for this, given that g prime is crappity crap, nobody cares, whatever this is. Okay, and write down the equation for solving for g of 2. Okay, hopefully you hit pause and hopefully you did that. So let's see, g of 2 will be g of 6, the one I know, plus the net change from what I know to what I need of the derivative. Oops, this is g though. That is the correct setup in the correct order. But that might make some of you uncomfortable, because normally the smaller number is here. Well, it's okay. If you put it into your calculator as is, your calculator will do the correct math and you'll get the right answer, because you can evaluate things in the reverse order. And if you visualize subtracting this guy, it is still g of 2, the top number, minus g of 6, the bottom number. So it'll still work. If for some reason you just cannot deal with that, it's driving you crazy, we did learn that there's something you can do to these bounds if you'd rather that they be in order. So what is that? Okay, you can reverse the bounds if you really want to. So leave the g of 2, leave the g of 6. Okay, and if I reverse the bounds, if I say, oh, I don't like them like that, that's bugging me, and you want to do this and make it 2 first and then a 6, you can, but remember what you have to do if you want to flip those? If you flip them, you have to put a negative out front. These two things are equivalent. They would both give you the same answer in your calculator. Truthfully, I only do this. I only actually flip it if I'm integrating on a graph and getting area under a curve by hand counting squares like we've been doing. Then I need it to go in order from 2 to 6. If I'm just putting it in my calculator, I leave it like this and let the calculator do the work. All right, that's it. It's going to be a matter of training your brain today and reviewing a little bit from yesterday. You guys should start studying for your test and reviewing everything so far. You have all of the Riemann sums, the rules of integration, kind of like this rule was. And we have starting value plus net change and lots of motion problems, okay? Make sure you review everything you've done in the last 2 weeks. Go through the modules to see what those things are. Maybe rewatch some videos. Today's worksheet will be pretty short, I think. Okay, good luck. Bye. Hope you're doing well.